Hello! In this video we're going to be talking about geometric sequences. First, let's see if you can identify a geometric sequence. Now, we have already learned in the past what arithmetic is. Arithmetic is when we are either adding or subtracting. Geometric then is going to be when we are multiplying or even dividing. So let's take a look. We go from 0 to 8 to 16 to 24 to 32. Now, to be geometric, we'd have to multiply. Is there anything you can multiply 0 by to get 8? No. So it's definitely not geometric. Let's see. To get from 0 to 8, we could add 8. Let's see if this works. Plus 8, plus 8, plus 8. Yep. So this would be arithmetic because we are adding 8 to each term. Now, just as a source of reference, if you remember how to write the equation for this, actually, you know what, we will do that later. Let's just keep moving. Determine whether the sequence is arithmetic, geometric, or neither. Okay, so to get from one to the other, let's see if we can add or subtract. Okay, so to get from here to here, if I minus 16, I get 48. However, if I minus 16, I do not get 36, I actually get 32. That means it's not arithmetic. Okay, so let's see if it's geometric. To see if it's geometric, what could I multiply this by to get this one? Now, we already learned a lesson about writing an exponential growth or decay equation. And if you remember how to get that base, what we're going to do is we're going to write a ratio. So let's see. 48, remember it's new over old. So new output over the old output. So let's see. 48 over 64. 12 goes in there. Not in there. Let's see. This is actually 3/4. Okay, so let's see if I multiply everything by 3/4 if that works. So 64 times 3/4, yep, does give me 48. 48 times 3/4, see 4 goes in there once, goes in there 12 times, yep, that gives me 36. 36 times 3/4, yep, it goes in there 12 times, that's, what did I miss here? Whoops, that should be a 9, not a 12. 9 times 3 is 27. So this looks good. This is definitely geometric. And what we're multiplying everything by is actually 3/4. So once again, let's determine which one this is. I would have to add 6. Add 6 does not give you 49. So let's see. If I multiply by 7, yes. If I multiply by 7, I do get 49. So that means this is geometric. Determine whether the sequence is arithmetic, geometric, or neither. So let's try again. If I add 1, I get 2. If I add 2, I get 4. Yeah, that doesn't work. Doesn't give me 14. So it's definitely not arithmetic. Let's see. To get from 1 to 2, I would have to multiply by 2. If I multiply by 2, I do get 4. But if I multiply by 2, I do not get 14. So it's definitely not arithmetic. It's not geometric. It must be neither. And it is. This time let's find the next 3 terms. So it's telling you that it's geometric. So we know that this is geometric. So we know that we're multiplying here. So what do we multiply 1 by to get -8? Again, you could always do the ratio if you wanted to do the ratio. And that would be a new output over an old or previous output. Okay, so that would be -8 over 1, which is -8. So that means if I multiply by -8, I should get 64, which I do. If I multiply that by -8, I should get 512. And I do. So now I'm just going to take my calculator and I'm just going to multiply the next 3. So I'm going to do this times -8. These numbers are going to be large. Whoops. Hit the wrong button there. So these numbers are pretty big here. So we get 4,096. And on my calculator, I'm going to multiply by -8 again. And I'm going to get negative 32,768. So I'm going to multiply by -8 again. And this time I'm going to get 262,144, so 262,144, and that's all they wanted me to do. Okay, find the next 3 terms in the geometric sequence. So this one, to get from here to here, looks like we're dividing by 2. If you want to do it as multiplication, here's what we're going to do. We're going to do a ratio of the new over old, basically your previous output. Okay, so that would be 20 over 40, which is a half. So it looks like we're multiplying everything by a half. So if I multiply this by a half, I get 20. If I multiply that by a half, I get 10. If I multiply that by a half, I get 5. Half of 5 is 2.5. 2.5 times a half is going to be 1.25. Multiply that by a half, and I'm going to get 0.625. Okay, find the next 3 terms of the sequence. So first of all, we need to figure out what are we multiplying by. This one's a little bit easier to tell. It looks like we're multiplying by -5. Again, if you want to tell what we're multiplying by, you're going to do new over old, or basically your previous. So take a new output. I could take 25 over the previous output, which is -5, so that gives me -5. So that means I'm multiplying everything by -5. Okay, so let's multiply -125 times -5, and let's see what we get. I'm going to get 625, so I'm going to multiply that by -5, and I'm not even looking at the choices right now. 3125. Now I can actually look at the choices because I have 2 outputs. It looks like D would be the correct answer there, and it is. Let's do this again. This one looks a little bit more complicated. Clearly we're multiplying by something here. Not sure exactly what it is, but to figure out what it is, remember, you could do a ratio. The ratio would be a new output over an old or previous output. So let's just take these 2 right here. So the newer one would be 200. The previous would be 800. So that's 2 over 8, or 1/4. Or if you like, 0.25, doesn't really matter. So basically I'm taking a 1/4 each time. So multiply that by a 1/4, multiply that by a 1/4, multiply that by a 1/4, and so on. So I'm going to multiply this by a 1/4, and that's going to give me 25 over 8. And there's only one choice that has it as my next value. It's got to be B, and it is. Okay, so let's talk about the formulas. If you remember these, there's 2 formulas. There's one that's called explicit, and that's a great formula because that's the one that you can use to find any term. So you could use it to find the first term, the second term, the third term. You could use it to find the 100th term. So in this one, it's going to be a sub n is equal to, you're going to do your first term, and you're going to multiply it by that ratio. That ratio, remember, to get that, we're going to do new over a previous output. But your power is going to be n minus 1. So that's your explicit formula. Remember, you could also see it as f of n is equal to f of 1 times your ratio to the n minus 1 power. So you could see it either way. Just so that you know, your regions will give you this formula. Recursive, this is the one where you have to do one right after another. So in this one, we always have to give ourselves a starting point. So you have to tell someone, okay, a sub 1 is equal to whatever. And then to get your next terms, you're going to do a sub n is equal to, now this represents the term right before. So take the number right before and multiply it by your ratio. That's it. That's all there is to it. Again, you could see it, instead of using a sub n, you could see it as f of 1 is equal to whatever, and then you would have f of n is equal to f of n minus 1, that represents the term right before, times your rate. All right, let's do a little bit of practice here. Okay, this time we're going to write an equation, and we're going to do both. We're going to do explicit and recursive. So, to find the nth term, so basically what we're going to do is we're going to say, first we need to find our r. So to do that, you can take any two consecutive outputs. You're going to do the new over the previous. Again, this is what we did when we were writing the equations from the graphs. This was like our second lesson in this unit. So negative 2 over 1, so that means my ratio is negative 2. My first term clearly is 1, so here we go. A sub n is equal to a sub 1 times your ratio to the n minus 1 power. So the formula is a sub n is equal to 1 times, oh, actually I think I'll use parentheses here because I have a negative base, so negative 2 to the n minus 1 power. There you go. Some of you will ask whether or not I need to have the 1, and the answer to that is no, I don't need to have the 1. Your recursive formula would look like this. A sub 1 is equal to 1. A sub n is equal to a sub n minus 1 times, oh, actually, there again, probably should use parentheses, negative 2. That's it. Just says take the term right before it and multiply by negative 2. Let's try again. Find the 12th term of the sequence. Oh, well, actually this is the same formula as the other one. So it's the same sequence. So I'm going to take this formula. Now of the two, to find the 12th term, if I use recursive here, if I use this recursive, I'd actually have to do this all the way out. So I basically have to do this 12 times. They did give us the first 4, but then I'd have to do the next. So I'd actually have to do 8. I think I'm going to go with this one. So this one was a sub n is equal to 1 times negative 2 to the n minus 1 power. So if I want the 12th term, I'd go a sub 12 is equal to, now I really don't need that 1, so I'm going to say negative 2 to the 12 minus 1 power. So a sub 12 is equal to negative 2 to the 11th power, and now all I have to do is just put that in my calculator, and that should be a lot easier. So negative 2 to the 11th power is actually negative 2,048. Done. That's the beauty of the explicit formula. This one, write an equation for the nth term of the following geometric sequence. Well, first of all, let's find our r. Remember, to find our r, we're going to do new output over the previous or an old one, but it has to be the term right before it. So I think I'll use the easier numbers here, so I think I'll go with negative 12 over 3, which is negative 4, which a lot of you looked at right away and said, okay, it's got to be negative 4. So a sub n is going to be your first term times your ratio to the n minus 1 power. So let's plug everything in. So a sub n is equal to your first term, that's your 3, times your ratio, actually it's a negative, so we've got negative 4 to the n minus 1 power. Clearly, that's choice A. Just for kicks, just to show you the recursive, your a sub 1 is going to be 3. Your next terms are going to be, take the term right before, and you're going to multiply that by -4. So that would be your recursive. Find the 7th term of this sequence. Okay, so it's using the formula, and we want to do the 7th term. So to find the 7th term, all you're going to do is take 7 and put it right in place of your n. So a sub n is equal to 3 times -4 to the n minus 1 power. So a sub 7 is equal to 3 times -4 to the 7 minus 1 power. So a sub 7 is equal to 3 times -4 to the 6th power. And all I have to do is just punch that in my calculator. And I'm getting a sub 7 is equal to 12,288. So it looks like choice C. Let's check it. And that is correct. Okay, so here's a Regents question. And this is the Sierpinski triangle. It's a type of progression where an equilateral triangle has a fourth of the area removed. So this is definitely going to be decay. Okay, to create the new shape. Then a fourth of the remaining area is taken away. So each time we're actually taking away a fourth. So what we need to do if we're going to write a sequence, a sub n is equal to a sub 1, careful, that's a of 1, times your rate or your ratio to the n minus 1 power. Now this is kind of interesting because I know what a lot of you are going to say. So first of all, a sub n is equal to a sub 1, which is actually 48. 48 times your ratio. Now let's get the ratio here. We've got two values. So remember, we're going to do new over previous. So it's going to be 48 over 64, which is 3/4. So this is actually 3/4 to the n minus 1 power. Now I know what you're saying. You're thinking the 1/4. But think of your exponential growth and decay formula. 1/4 wears away, and therefore 3/4 actually remains. If you think of your exponential growth and decay, let me get a different color here. There was a formula that we learned. So that would be y is equal to a times 1. Now this is going to be decay here, so it's going to be minus r to the x power. So this is kind of interesting here because this one is different than your sequence. A little bit different. Your a is going to be your initial value. This is your y-intercept. So this is your y-intercept. Here's your y-intercept right here. So this formula is actually going to be 64. 1 minus, now this decays at a rate of 1/4 to the x power. So this is going to be y is equal to 64 times 3/4 to the x power. Both of these represent this situation right here. Now what I want you to notice is the real difference here between the two, because I know you're confused as to why one starts off with 48 whereas the other starts off with 64. Let me show you what compensates for that. Look at the exponents. So this exponent is actually n minus 1, this one's x. That's the difference between starting with this 48 and the 64. Let's look at it graphically. For a geometric sequence, the first term is described as 16. So in other words, if I were graphing this, So if I were graphing this, your input is n and your output is a sub n. So first term is 16. Now what this says is take the term right before and take half of it. So that means my second term would be, again, take the term right before, take half, 8. Term right before, 8, and take half. So this is going to be 4. So hopefully you're starting to see the pattern here. Fourth term is 2, and we have to do the first 6 terms. Okay, so when I graph this, my first term is actually 16. That's right here. And then my second term is 8, my third term is 4, then 2, then 1, let's move this recording thing, and then a half. By the way, I do not connect the dots. This is discrete data. There is no data between the dots. This is not a continuous graph. So basically, the difference between the two, so if you have a sequence, I've already put the dots on there. If you have a sequence, the formula for this one, this is the question right before, a sub n is equal to first term, so a sub 1 times your ratio to the n minus 1 power. So this would be a sub n is equal to 16 times 1/2 to the n minus 1 power. If we look at this as regular exponential decay, which is your formula of y is equal to a to the 1 minus your rate to the x power, this would be y is equal to, believe it or not, this a is different than a sub 1. This is your y-intercept. So your y-intercept would actually be, for this one, 32. So this would be 32. Now we already know 1 minus the rate would actually end up being a half. It's going to be the same base here to the x power. So essentially the graphs are going to look the same. However, the difference in the formulas here is essentially this part right here. So the part that is different, again, is that this is your a sub 1. This is not your y-intercept. That's your first term. That's the output for the first term, which is why we have the n minus 1 power. Whereas in your exponential decay formula, this is your y-intercept, and you just have x to the just x for your power. So that's the biggest difference between, say, your sequence. Put an e on there, that's going to drive me crazy. So now that's fixed, and we are all set. So what I'd like you to do is I'd like you to practice writing some explicit and recursive formulas for geometric. I'm also throwing some arithmetic in there. I put the formulas on the page for you, so if you didn't jot them down from this video, don't worry, they're actually in there. And good luck!